Welcome back. Welcome back, welcome back. It's time for PKOS again. We're continuing this battle with VGA. And I think I've made some headway here. So first of all, writing all of those registers wholesale was bad. What I was able to do is go back to the way it was done previously, which is just upon entering VGA, set the alphanumeric disable to turn off text mode, and set the mem map to a different mem map. So maybe we don't even have to do the mem CPY. Ignore all this stuff. And then I'm actually able to work with the sequencer by very carefully setting things, synchronously stopping it, forget the screen display thing, but I'm able to turn on the extended memory register right. Well, here, let's go look at what that was. So right here, basically, if we set this to 0xe, if we set this to 0xe like we are, it's turning all three of these on. So we're turning on chain 4, we're turning on odd even, disable, whatever this is, and extended memory. So this is what gets us the, it gets us closer to the tiny pixels. So unless we turn this on, it assumes that we don't have 256 kilobytes of memory. We only have 64. So that kind of explains why you get some smaller looking pixels that are still quite messed up, but it looks definitely different when you set that up. I'm also able to set the map mask. Where is that? Right here, map mask register. Set that to F, which just enables write to all 4 planes. And we get what you just a little bit further. And if you don't set that, check this out. If you don't set up the extended memory and the chain 4 and all this stuff, you get these red splotches. Watch how they go away, and watch how everything shifts up, or appears to shift up, because it gets smaller. So I'm just setting 400 bytes to 0 at that display memory that I set, A0000, and what happens is everything will shift on down when we turn on the sequencer thing. So yeah, so it's scrunched right up there, and you can see that I'm setting a few pixels and they come up as these little blue lines, so not really showing up, but there's no red splotches. It's perfectly clearing the background, which is great. So that's where that's at, and we are able to get back out because we carefully unset all of those fields in the sequencer in particular, and we do it kind of in reverse order, almost like a stack. So we reset the sequencer again, and we set all of that stuff turned off, and then we turn the sequencer back on. And then we unset the text, or we turn text mode back on, turn alphanumeric disable off. To enable alphanumeric mode, we set the RAM enable, and then we change the memory plane that we're using back to B8000. So all of that works. What doesn't work, if we uncomment all of these special CRTC values, we get the very exciting tiny pixels that we're looking for. Right? That looks awesome. But if I hit escape, I'm back to a blank screen, and you can see I can move back and forth between these modes, but I'm definitely losing something in text mode along the way. So these tiny pixels are exactly what we want, but what are we losing? So my theory is that when we set all these CRTC values, in particular, if you set this max scan line to 0x41, you will notice this behavior. Otherwise, you won't. Actually, I think, whatever. Take my word for it. Actually, I have it set right up there. So I'm only setting that one register for max scan line, which I think is how far down the pixels go. We set that, and actually, okay, so that does not give us tiny pixels, but also doesn't make it so we can't get back. So I don't know. I'm talking about stuff that I don't know about, so let me stop. But so serious progress there. However, I think my theory is that we are overwriting all of the VGA fonts when we do this. So the solution to that is to get more familiar with text mode fonts so that we can save the text mode fonts and return to them. So how do we do that? Well, it turns out that the sequencer also selects a character set for a font. So you can select up to 1, 2, 3, 4, 5, 6, 7. It looks like you can have 8 different fonts stored in memory, and you can have 2 character sets. So like I guess a primary and an alternate. And apparently for EGA compatibility, whatever that ancient technology is, they do not store the bits next to each other for these character sets. So, and oddly enough, these online VGA docs note that it's character set A and B. However, if you go into the hardware manual, primary and secondary is the language that they use, and map B is noted as primary. So when I was playing around with this, it actually does have an effect if I modify the primary one. So I'm going to go with the hardware docs and assume that they're correct. So it seems by default that the primary is selected. So if I go VGA font, you saw that I just changed that bit 0 to all zeros. So it doesn't actually change the font address, but if I change it to 1, we get VGA font. Everything goes away because all the characters are zeros. Everything is black. So that's exciting stuff. I'm going to actually probably commit this and just say, you know, add code to switch fonts. Now, can we copy the primary font over and retain it? So maybe I can just say this whole block here is set font, change font. And maybe we can work on copy font 0 to font 1. So the way that these registers are set up, it's a little weird. If we take those first two, if we take these second 2 bits, so actually we really just need to left shift if we're going to use map B or the primary, but we're just going to left shift these by 1, and then we're going to and in right shifting by 4, I think. So primary map is bit 4. We'll shift that over to position 0. And do we have to AND it with a mask of some sort? 7, 6, 5, 4, 3, 2, 1. And then we'll shift it over. So let's make sure that the current font, let's not set the font right now, but make sure that we're actually detecting the right font number. So VGA font, current font is 0. If I set the, so this is primary bit 0. So if I set the, that bit, which is the 4th bit, to a 1, we should get a map of 1. So it should select map 1. Let's see if that comes out correctly. Well, first it actually gets messed up. So instead of actually setting it, let's just use that same value that we would have set it to for now and make sure my math is right. So instead of shifting curve font, let's just actually set curve font to that literal and see what happens. So if we do VGA font, that didn't seem to work. Oh, I don't think that I did that right. So we want bit 4 to be selected. That should be a 1. Why is that not a 1? Oh, I shifted it first and then well, okay, so I think I have to move that bit over 1. Maybe I have to go 1 in that direction since I shifted it. That's really confusing. Ugh, why does it have to be like this? So let's take this one at a time. So we're going to say primary bit 0 equals curve font right shifted 4, and then we're going to AND that with 1 so that we only get that 1 bit. Then we'll say primary bits 1 2 equals cur font right shifted 1, or no, actually it would just be cur font ANDed with 1 1. And then we can say char set A is primary bits 1 and 2, left shifted 1, ORed with primary bit 0. Okay, I think that's right. We don't have to do that anymore. Let's see if that's correct. So in theory, we should see a 1. Yep, looks good. And then if I set these two, we should see a 7. If everything's working right. Yep, looks good. And if I change the left or the rightmost one, which is supposed to be bit 1, that should result in 101. So let's see if that is the case. Yep. Okay, so I'm pretty confident that we're actually getting the right character number now. So that's good. So we changed the font. So now we can detect the font, at least. Let's see. Doesn't do us much good if we can't print to the screen. I guess I can use the debugger, but let's... so the font is 0. And it says in the manual that for font 0, let's see. Primary map select. Offset from where, though? That's the question. So we'll refer back to the other docs. So if it's set to 0, it's selecting font at 0. Oh, so that's offset 0 as well. So I think it's okay. So font selected resides in plane 2. So plane 2, it told us elsewhere is actually, where did it tell us that? Ah, man. Plane 2. Oh, I have that as a constant somewhere. Plane, here we go, plane 2. So that's B00000. Okay, so if we take B0000, so it's directly at B000. This other one is at 4000. So what we can do is, I'm lost. Where is VGA.c? Here it is. Okay, so what we can do is copy. We can do a memcpy from, actually I forget what the operands are here. What is that, standard lib? No. I have a memory section, okay. Memory dot, alright, so fill or source. Oh, memset versus memcpy, okay, so our source and our destination. So we're copying from, that's kind of a weird way to do it, but we're copying from the plane 0 address. Let's just do 100 bytes to start with. And then we're going to copy to plane 0 address plus the offset of 4000 hex. And let's just copy 256 bytes. And then in theory, when we switch to font 1, which we'll do here by doing, so bit 4, bit 3, 2, 1, 0, that's a 7, right? So we actually want font, we actually just want 1, right? So if we copy that over, we should see at least some of these characters printed, hopefully. Let's see if that pans out. Nope, it didn't. That's sad. Well, you know what? I don't know what font I'm selecting, but hold on. Before I get crazy here, I should be copying plane 2, not any of that other stuff. So it all exists in plane 2. So let's use plane 2. And then we can say VGA font, cross our fingers, and nothing happens. Okay. All right, let's try just doing all of the offsets. Maybe I need more than 256. Let's just, how much? Looks like it's 2000 hex, so let's just do the first 1000 hex, which is a lot. VGA font, so that didn't work. maybe it's the wrong font. So let's also copy from plane 2. So is this actually, it must just be selecting the wrong font, right? Like we're not crashing everything. Yeah, so let's just try 8000 hex, C1000 hex. Wait. So the offset is 4000, 8000, C, 2000, 6000. It's confusing, so I definitely could have had it wrong. 2000, 6000, A1000, E1000. E1000. So let's see. VGA font. Ooh, interesting. So we definitely made a change here. Whoa, that's so interesting. Why did that happen? So it's all set to ones for that top piece. Whoa. So we definitely affected the font. I don't know why it's set to all white. I wonder if maybe... What's going on here? Oh, so these are all set to do 256. So at some point I copied... Wow, that's interesting. All right, so I'm curious what is actually in memory. So let's try running debug mode and breaking right before we start doing all these crazy copies. And check some of these memory addresses to see what's really there. So if we do break vga.c 59 right before we do a mem copy, then we do VGA font, it's going to break. And we can check out, I forget how to do it exactly, p/x, b8000 at least should have some text in it, right? So we should be able to print characters or something, right? And see the PKOS thing. I'm going to ask ChatGPT. How do I print the characters starting at... Let's print 16 characters. Something like p/c. Oh, examine a string. Okay. p/s. That didn't quite work. Maybe it did. That doesn't look like what is displayed on screen. Oh, I'm using P. I need to examine X. Aha, there it is. So yeah, it has that \A to indicate the color, but that is exactly what's there. So now that I know how to examine memory again, we can look at 0x. What is plane 2? Can I actually just use that constant? No, I can't. Okay, so vga.h plane 2 address is a quad 0. So it's all 3777. So what if I do a... That actually worked. Okay, cool. 2000, 4000, 6000, 8000. None of these have anything in them. Is that right? No. So where is the font if that's not it? What the heck? That's pretty annoying. Oh, plane 2. I'm using plane 0 address. I'm an idiot. Okay, so 0xb 1, 2, 3, 4. What's that look like? Nothing. How about 2,000? How about 4,000? 6,000? 8,000? Oh, there. Huh. 8,000, we already ran into the other one. So how are they storing that much stuff in plane 2? That is confusing. Not really sure. So, yeah. What do we do now? I needed to figure out where this font stuff is defined. So, plane 2 of display memory at the address specified by this field, which I'm 99% sure that I have those addresses correct. Where did it define the... Somewhere it definitely talks about display memory. Maybe in the graphics register. Oh, here it is. Memory map select. How does that differ, while we're thinking about it, from the character map select? Okay. Alright, interesting. I wonder if I can turn off... writing to the memory plane 2 to prevent the font being overwritten. That's a thought. Did I... let's try that actually. And then we can go back to figuring out where the font is. But what if we turn off... When we VGA enter, what if we turn off the ability to write to plane 2, since that's where the fonts are, and the fonts are getting erased? What did I mess up here? Oh, it's already open. So that's a thought. We can get in, we can't get out. But what if we block updates to plane 2? Memory plane write enable. That's in the sequencer. So when we do our sequencer stuff, are we even messing with that? Memory plane write enable. Oh, the map mask. That's right here. So the map mask is here. So if we change that instead to 0B1011, we should be disabling writing to plane. Okay. Back to it. Back to it. Back to figuring out this font stuff. So what am I missing as to where this font is stored? So right from the cat's mouth, we have planes defined. Memory map select. This might be common enough that I can ask and just do a sanity check. What is the plane 2 address for VGA memory? A000, is that right? Just curious what it says. So plane 2, 0, 1, 2. No, I don't think that's right. Maybe I'm wrong. Interesting. Okay, here we go again. Alrighty. What am I missing here? I know, let's see. It really seems like this is plane 2. That's actually not the address that I was looking at, is it? Plane 2 address is what? In my code. Plane 2 B0000. Let's try this again. Line 59. Dang it, I didn't mean to do that. Okay, VGA font. Okay. And it continued again. Alright, let's just start over. Break VGA.c 59. VGA font. Okay, examine as a string memory location 0xb000. Really nothing there. Plus 0. I can't believe it. Why? What's the deal? Why is it like that? What about B7FF? F. That's right where the other memory starts. It's all 377. There really seems to be nothing there. Alright, let's check these other planes. Ooh, what's this? Oh, I think this is the end of display memory. So it's just blanks. That's obviously what's on the screen right now, B9000, BA. This is all display memory. Alright, new experiment. We can get into VGA, we can't get out. What if we never change the memory map like we were before, but instead we intentionally select the same one as text mode? So the B8000 one. So in theory it should never overwrite the fonts, right? Maybe? So VGA enter, we set the memory map to 0, 0. Is that B8000? Yes, it is. So let's set it to 1, 1 for sure. Forgot a semicolon, as usual. If we set it to 1, 1, what happens? We go into VGA, we come back, everything's still messed up. But it doesn't partially clear the screen because I'm only writing into plane 2. Now, what if I change this to write to plane 2 again? Or I'm only writing to plane 1. Let's write to plane 2. Will we see that reflected? I think we probably will. We don't. Interesting. Or was that the memcpy that was doing that? Yeah, let's try changing that to B8000. There we go. You do see it clear a little bit of the screen. And we get nothing back when we restore. Okay. So, fine. And what exactly is messing everything up? I think it's this it's the CRTC stuff, right? So let's just not do that part and make sure we can still get back. So CRTC, let's just not set that register, and then VGA, and we can get back. So it's good. Whoa, that's awesome. Actually, I'm typing, and you can see it modifying the memory right in front of me. Clear. Whoa, that is so crazy. I'm still typing. Whoa, look at the prompt. The prompt, enter, 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 enter. That is wild. Let's keep going. So I can get out. I can get out. So if I go back into VGA mode, I wonder, oh, look at this red stuff. This red stuff might be the font. So it loops around. Oh, that's crazy. So those red bits down low might very well be the font we're looking for. I wonder if that's the case. That's so crazy. Clear. I can get back. Clear. VGA. Okay, that's pretty entertaining. What does this mean? So let's play with this. Let's test that theory. If that is actually what I think it is, and that's where so we're only messing with that little piece of memory right there that you can see. I'll do VGA info to really print some stuff. Okay, yeah, you can see we mess up the screen up to a certain point right here. So if I start clearing and we get past that point and we start to get into here, do we lose our font? That is my question. So we're writing 400 and the black is getting to right about here. So if we double it, 800, 1600, 3200, let's try 3200 and see how far that gets us. VGA. So we clear quite a bit and we can still get back and have our character set. No problem. So we go in. That's so cool. It's funny that there's all this garbage that is in between somehow. I hope that the font info is not like interspersed. Oh, and then I clear and you get the stripes because you're setting the color bit. Is that why that's there? And then we escape out of it. We go back in, it clears it again. That is so awesome. Oh. Okay, we're back. VGA, back. So let's increase the amount that we're clearing out here to like 4,500, I guess. See how far we get. Probably, okay, so we're pretty far down there. We're actually past the point where we're modifying it with the screen. So, right, I don't think we're even reaching that far down. So if I get out of here, font, screws up the font, and I think the exclamation point got erased. So if we go just a little bit further, let's see if that continues to erase the font. So we went a little further, we go back, VGA font. I don't know. I don't know if this theory is going to pan out. Let's keep erasing more. VGA, and we go back, VGA font. We lost the asterisk. Hold on. Let's add that into VGA font. Asterisk. So let's do that again. If we do VGA font now, we get that. If we do VGA and go back, the asterisk and the exclamation point disappear. VGA font. Wow. Okay, so what if we keep going? Just a little further. Or was it 5,500? Let's just do 6,500. 7,000. VGA. Almost to the end. VGA font. We lost a bunch of numbers. Okay, so that must be where the characters are defined down there. 7,000. 8,000. Maybe if we continue until... If we continue until we've erased all the characters, then we know how much memory we need to save. We're not saving enough of the video memory elsewhere. That's everything. It's all gone. And then we say VGA font. We still have a bunch of characters. How far do I have to go to get to the alphabet? Let's try 16,000. Let's double it. VGA and go back. Now we have nothing. So what is this in hex? Okay, so how about we just copy 0x3FFF. If we wipe 3xx, so VGA, we go back, we got nothing. Okay, fair. Where are we saving? We're saving off stuff right here, but we're only grabbing calls times rows times 2. So instead of that, let's grab 0x3FFF and then see if we can restore it back. VGA. That didn't work, but I don't think that I updated the restore. So let's go back down to the restore. And instead of calls times rows times 2, we'll do that. Copy it all back into place. And that did not work, unfortunately. Dang. VGA. Back. VGA. I mean, we're editing the video memory, but it looks nothing like what it was before. So what happened? Clear. Yeah, that's really interesting. We can actually visualize what's going on here. The memory is just getting wiped. But I'm wondering why. Is it because this memory location that I'm copying to is not valid? Let's see. Let's see what that looks like before and after we copy out there. So when we enter VGA mode, right before we do the mem CPY, let's see what it looks like. And then we'll look after that too. And then we'll be good. So let's break at VGA.C, line 89. Continue. VGA. And we can examine as string. B8000 looks fine. And then we can examine as string 0x10 B8000. There's just nothing there. Go to the next line. Should have copied. It is there. Okay, let's break again when we go back. When we memset. Oh. Yeah, let's do that. Let's check it when we go back. Actually, I might, yeah, I gotta keep that memset. Yeah, that should be fine. Okay, so let's check it on our way back. So if we go to this memcpy, that's going to be a break at vga.c 248. Continue. And we went to the breakpoint. Let's examine a string 0x10 b8000. It's still there. Examine a string 0x b8000. Nothing's there. Next. Examine a string b8000. It's there. It is definitely there. Plus OX300. That's also there. Yeah, it looks good. Oh, are we not setting the plane back properly or something like that? Memory map P8000. On the way in, what do we do? We should be setting the memory map to P8000 as well. Okay, so we are doing that. Then I'm confused why this is not reflecting in what we're seeing. Why is it the case that when we erase that stuff, it goes away, even if we copy it back? So what's going on? Maybe it's a question for another day. Getting a little tired, but we can keep pushing and see if we can break through here. I think we're close. We're really close to something good happening. Clears it, and then, yeah. So, very strange. Maybe, what if I clear less? Because I'm really going pretty hard on the clearing here. What if I only clear FF? Mem set. Yeah, so that clears the first line. We go back, we're fine. It doesn't put it back the way it was. I don't know why. Is it, what's going on here? Why is this not working? And how's it restoring the text on the screen, but not any of those middle things? I wonder if there's a problem with my mem set, my mem CPY, I mean. Because it's using those stas B things, move SB, store SB. But I'm pretty sure those are right. I don't know. What if I mem set it all to 1? What would that look like? Instead of 0. Will it all turn white? Yep, it does. Does the whole screen turn white when we do all of it? Yes. And then we get this grayscale with stripes. What are... Odd. Oh, because it's interpreted differently for sure. But there's just no character set. So there's just lines. I guess the lines are the separations between the characters. Huh. Wow. I'm really not sure. So I think the thing that we figured out today is that the font info is within the 0xb8000 area, because we're clearly destroying it when we write too much data to that area. What I don't get is why we can't restore it. So I'm going to commit this and think about it, and come back to this later. But I really want to wrap this up because it's been a lot of work on this VGA stuff. So mess with font, write all 1s to plane 2. Or actually plane 3. Alright, I have no idea what's going on here, but I think we've made some progress. We're getting really close here. It's just what's going on with this mem setting stuff. I have no idea. So I'm gonna sleep on it and come back to this later. But yeah, if you liked this for some reason, thanks. Like, subscribe, whatever you gotta do, and we'll do more of this later. Okay, have a good night.